Hey everyone, continuing the last question type, we have geometry. When it comes to geometry, usually you'll be tested on quadrilaterals and their different properties. And when I talk about the different properties, usually the angle properties. Alright, so angular properties. And to determine or help you decide what kind of quadrilateral you obtain from the points, the idea of vectors in the Argand diagram would help you. Alright, as you see from this example, where we have z equals to root 3 minus I, and we want to sketch on the Argand diagram ABC the points that represent z, iz, and z plus iz respectively. And then they want us to state the geometrical representation of OABC. So let's do that first. And we start off with the Argand diagram. And you notice that I don't draw the origin now because I'd like to sketch everything first and then pick a more appropriate spot to put the origin. So let's start with the complex number z, which is represented by the point A. So z equals root 3 minus I think it's quite easy. First of all, express it in exponential form. Alright, because if you notice in the hence, we have argument and then anything to do with trigonometry. Alright, so let's do that first. Z equals to, modulus is 2, root 3 square plus 1 square is 3 plus 1, so it's 4, root 4 is 2. EI, now this is in the fourth quadrant, so it's basically the negative of the basic angle. Basic angle, tangent inverse 1 over root 3, it is simply pi over 6, so our argument is minus pi over 6. So let's try to make it here being a 1, or rather root 3 comma minus 1. Now, iz. So what does iz do? I, complex number, exponential form, ei, pi over 2. So ei pi over 2 times z, basically a rotation about the anti-clockwise direction by pi over 2. So simply, somewhere around here, I guess, is b. And we know that this must be a right angle. So what happens though, you notice that it is in the positive side, it is 1 comma root 3. Now, you can do it manually, or if you do it by experience, you know that whenever times I, the numbers would swap and the imaginary would become the opposite sign, the real would remain at the same sign. Alright, so root 3 becomes imaginary root 3 minus 1, imaginary became the real and it changed sign. That's what I meant. Alright, z plus iz. So what you guys might do incorrectly is try to factorize. Alright, it's not really incorrect, it's just longer. Obviously still can do it. This will then give you z and then ei pi over 4, which is fine. Alright, you then can do it from ei pi over 4. But the more efficient way is to recognize that z plus iz, so this is the complex number z, and this is the complex number iz. It's just basically vectors. Right, so z, this is quote unquote iz, so go down and then go up. Right, so it's something like OA plus OB, so OA plus AC is basically this would then give us C. And notice that all the sides are the same, and you have a right angle, all four are right angles. OABC we know is a square. Alright, with the same sides, so they are a square. Now you can label point C. We can do it because you know that we have z plus iz, so you add them together, 1 plus root 3 comma root 3 minus 1. Hence determine the argument of z plus iz, essentially determine the argument of OC. So you know that in a square, when we were to cut along the diagonal, this angle is pi over 4, alright, 45 degrees. As such, we also know that this was pi over 6. So the on top angle is simply pi over 4 minus pi over 6 equals to pi over 12. Alright, so this is what I meant by knowing the angular properties in non-quadrilateral, particularly the diagonal of each quadrilateral. It will bisect the angle. Hence deduce that tangent pi over 12 equals to 2 minus root 3. Now we have the complex number of c, 1 plus root 3 plus root 3 minus 1 I. And we know that the argument of z plus iz is pi over 12. So we know that tangent pi over 12, very back to the basics, y over x, root 3 minus 1 over 1 plus root 3. Rationalize the denominator, times 1 minus root 3 on top is 1 minus root 3. Alright, so on top I think it's quite obvious, it's basically minus 1 minus root 3 square. Below is simply 1 minus 3. 1 minus root 3 square, 1 plus 3 is 4 minus 2 root 3. Below, 1 minus 3 times a minus, so it's minus 2 minus, so it is 2. We then have 2 minus root 3. Alright, so be careful, this is algebraic, so it's actually 1 minus 3 if it's 1 plus root 3i times 1 minus root 3i, then it's 1 plus 3. Alright, so take note, this is not in complex numbers anymore. Alright, so we have deduced that tangent pi over 12 is 2 minus root 3, and we do it because we use the angular properties of our quadrilateral. Alright, so this is the example for geometry, and in the next video we see another example before we head to the crash course video.